I'm Chandana. I am came back with my project Wish Band, and our group members are Aishwarya DT, Koal Debnath, L Shilpa, Lakshmi GB, and Noori Mujasim. And we did a wish band of our project, and I'm going to recap just the second review part of my project. Okay, here is the second review slide of our project. That this slide summarizes the work completed till the review too, and these are we clearly defined the problem statement and objective focusing on women's safety, and a detailed system architecture and block diagram were designed, and required hardware components and sensor were selected. Sensor data equations was successfully implemented, and the collected data was pre-processed and structure was proper analysis, and communication logic was implemented for alert generation, and finally the function simulation was completed, and successfully we have completed that second review part, and thus all planned objectives for review 2 were achieved, and the system is ready for further enhancement and real-time implementation. And I will go for a result part. Okay, this is the result interpretation explanation, where in this slide we present the result interpretation of our woman safety smart band system. And what are the data analysis of the result interpretation are during simulation. The panic button inputs and sensor values were continuously monitored, and threshold based logic was used to identify emergency conditions. The system was able to accurately differentiate between normal and emergency situation. Okay, this shows that the decision making logic of the system is working correctly. And what are the insights? We can say that the system provide a quick and reliable response during emergencies. The panic button ensures instant manual alert even if sensors fail. Okay, then sensor based detection further improves user safety by automatically emergency identification. And overall, the simulation result confirm the feasibility and effectiveness of the proposed system. Okay, hence the result validate that our system is reliable, responsive, and suitable for real-time human safety application. Thank you. And the next part will continued by our friend Noor Mujasim. Thank you.
Hello everyone, I am Noora Mujassim. Now I'm going to explain our system output. This slide explains how the women's safety system responds during normal and emergency conditions using sensors and alert mechanisms. First, coming to the force detection using FSR sensor. The force sensitive resistor continuously monitors the pressure of force applied on the device. When a normal force is applied, the system remains in monitoring mode. If the applied force exceeds a predefined threshold, it indicates a possible distress situation. The FSR sensor sends an analog signal to the Arduino Uno. Based on this signal, the system automatically detects danger without requiring manual input. Here, this feature enables automatic emergency detection. Now, coming to the visual alert indication, that is LEDs. Here we have used two type of LEDs. One is red LED and another one is green LED. Here, red LED glows when unsafe or abnormal force is detected, indicates that the system has entered emergency mode. Now, coming to the green LED, it remains on during normal conditions, shows that the system is active and functioning properly. Here, LEDs provide instant visual feedback about the safety status. Now, third one, coming to audible alarm activation, which is the buzzer. When an emergency is detected, the Arduino activates the buzzer. The buzzer produces a loud alarm sound. This helps to alert nearby people, attract attention immediately, create panic for the attacker. Here, audible alert increases the chance of immediate help and intervention. So, when abnormal force is detected, the system automatically triggers visual alerts using LEDs and audible alarm using buzzer, ensuring instant awareness and assistance. Thank you.
Good afternoon, everyone.
I'm Shilpa. I'm going to explain about performance assessment. In this, it had included reliability, time efficiency, and response time. Here, the performance assessment of the system shows the quick response when force is applied to the FSR sensor. With the Arduino activating the LED and buzzer within a millisecond, it works reliably within stable sensor readings and accurate alert as long as power is available, and the user of the low power components and simple logical makes the system efficient while providing effective safe alert. Thank you.
Hi everyone, I am Lakshmi GB. Now I am going to explain challenges faced. Software challenges. One major challenge was writing scalable and reachable Arduino code to currently interrupt the analog values coming from the FSR sensor. Since the sensor provides continuous analog data, it was important to process these values accurately. Another challenge was setting an accurately appropriate threshold value. The system had to clearly distinguish between normal pressure and emergency forces. A poorly chosen threshold could either miss emergencies or trigger false alarm. We also faced issue with false triggering of the buzzer and LEDs due to electrical noise and small pressure changes. Filtering and careful condition checks were needed to prevent unnecessary alerts. Additional debugging, timing, and continuous monitoring issue was changing. The system had to read sensor value continuously without dealing that could affect response time or system stability. Data challenges. The FSR sensor reading varied significantly based on different pressure levels and how user applied force. This made it difficult to rely on a single fixed value for detection. Environment factors such as temperature, surface conditions, and sensor placement also affected and readings, leading to inconsistent data. Another challenge was calibrating sensor values for different users since each person applies pressure differently. The system had to work religibly across real-time usage sensor. Finally, managing accurately analog data was difficult. The sensor values were not always stable, so extra care was needed to ensure accurate emergency detection without false alerts. Thank you.
Hi everyone, I am Aishwarya DT. Now I am explaining the limitations, improvements, and future scope of our project. Coming to the limitations, our system depends on internet or GSM connectivity to send real-time alerts. So poor internet can affect alert delivery. Next, battery life may reduce its GPS and sensors run continuously. Next, third, the threat detection accuracy can vary because sensors have physical limitations. So sometimes accidental movements may trigger false alert. These limitations are expected at the prototype and simulation stage. Next, coming to the improvement part, we can use low power optimization techniques to increase battery life. AI/ML algorithms can be added to reduce false alerts and improve threat detection. And multiple communication options like Bluetooth, GSM, Wi-Fi can be integrated on this project. The wearable design can be improved for comfort, durability, and water resistance also improved in this project. Next, coming to the future scope, the integration with the smart city systems and police emergency services, smart support for real time audio or video streaming during emergencies, and mobile app for live tracking, health monitoring, and alert history. And the system can be extended for child safety, elderly care, and disaster alerts. These are future scope of our project. Next, thank you.
Hi everyone, my name is Koel. I'm concluding with the part conclusion. So here the output of our project is IoT based women safety band. This developed system is an IoT enabled women safety band aimed at improving personal security. It integrates sensing, alert, and location tracking technologies into a single wearable device, allowing rapid response during emergency situations. Next is it detects using a FSR sensor. An FSR means force sensitive register is used to detect applied pressure during discharge or danger. Increased pressure on the band is sensed by the FSR, which triggers the emergency condition. This ensures that emergencies are detected quickly and reliably. Next, inserts alerts using buzzer and LED. Once an emergency is detected, the system activates a buzzer to attract nearby attractions, LED indicators to provide a visible alert. This alert helps people nearby recognize that the user is in danger, enabling faster assistance. Next, real time GPS location tracking. The system retrieves the display's real-time GPS latitude and longitude, allowing accurate tracking of the user's location. This information is crucial for rescue operations and help authorized or guidance locate the user quickly. The last point is portable and user-friendly design. Means the band is designed to be lightweight, compact, and comfortable, making it suitable for everyday users. It's simple design ensures that users can wear it continuously without discomfort. So now, what are the objectives we achieved in this projects are compact wearable device, as I mentioned. The project successfully demonstrated the design of a small and portable safety band, fulfilling the requirement of a wearable solution. Emergency alert system and effective alert mechanisms was implemented to ensure immediate response during danger situation. Real-time location monitoring by integrating a GPS module, the system enables accurate and continuous location tracking, improving the chance of timely rescue. Quick response mechanism. The combination of FSR sensing, buzzer alerts, and GPS tracking ensures rapid detection and response, minimizing delays during emergencies. And a simple push button operation. A push button is included to allow manual triggering of alerts. This provides an additional layer of safety, ensuring the user can activate the system even and if automatic detection fails. So overall, the conclusion is the women safety van provides a reliable, efficient, and easy to use safety solution by integrating emergency detection, alert mechanism, and real-time location tracking. The system significantly enhance personal security. Its wearable design and fast response capability makes it a practical and effective solution for real-world safety applications, especially for women in vulnerable situations. Thank you.